Good morning students. In this video we are going to learn about Introduction to Algorithmic Analysis. Algorithmic analysis help us understand how efficient an algorithm is in terms of time and memory usage. This topic is very important for data structures, algorithms and also for competitive programming and real-time applications. Let us start with the basic concepts of an algorithm. First, let us understand what an algorithm is. An algorithm is a finite sequence of well-defined steps used to solve a particular problem. Each step in an algorithm must be clear, unambiguous, and executable. An algorithm always has a starting point and an ending point, and it must produce a result. For example, finding the largest number in an array involves comparing elements step by step. So, an algorithm is simply a logical method to solve a problem efficiently. The next, what's an algorithm? Now, a question is, why do we need algorithmic analysis? Writing a correct program alone is not enough. This program should also run fast and useless memory. When the input size is small, almost all algorithms work well. But when an input size becomes very large, inefficient algorithms become slow. Algorithmic analysis helps us compare different algorithms and select the best one. Therefore, it is essential to analyze algorithms before implementing them. Algorithmic analysis is the study of an algorithm performance. It mainly focuses on two factors: time complexity and space complexity. This important point here is that algorithmic analysis is done independent of programming language and hardware. We do not calculate exact execution time. Instead, we study how the algorithm behaves as the input size increases. This helps us understand the scalability of the algorithm. Next, what is algorithmic analysis? Let us now discuss time complexity. Time complexity measures the number of basic operations performed by an algorithm for a given input size n. It does not measure time in seconds. Instead, it measures how execution time grows with input size. For example, if an algorithm scans all elements in an array once, the time complexity is O(n). Time complexity helps us predict how fast an algorithm will run for a large inputs. The next, space complexity. Next is space complexity. Space complexity refers to the amount of memory required by an algorithm. It includes memory used for input data and additional memory, such as temporary variable or recursion stack. Algorithms that use less extra memory are generally preferred. For example, recursive algorithms usually consume more memory because of function called stacks. So, space complexity is also an important factor in algorithm analysis. The next, asymptotic notations. To analyze algorithms efficiently, we use asymptotic notations. These notations help us describe the growth rate of an algorithm. Instead of exact value, we focus on how performance increases when input size becomes very large. Three main asymptotic notations are there: big O notation, omega notation and theta notations. Among these, big O notation is the most commonly used thing. Next, big O notations. Big O notation represents the worst case performance of an algorithm. It gives the upper bound on time or space complexity. Some common big O complexities are O1 for construct time, O log n for logarithmic time, On for linear time, On squared for quadratic time. Big O notation help us compare algorithms and select the most efficient one. Next, comparison of algorithm. Now let us compare algorithms using the time complexity. An algorithm with lower complexity performs better for larger inputs. For example, bubble sort has an time complexity of O n squared, while merge sort has O n log n. As the input size increases, merge sort performs much better. Therefore, algorithmic analysis helps us choose the right algorithm for real world applications. Next, the conclusion. To conclude, algorithmic analysis is a fundamental concept in computer science. It helps us evaluate algorithms based on time and space efficiency. Asymptotic analysis simplifies performance comparison. Big O notation plays a key role in analyzing worst case behavior. Algorithms, remember, an efficient algorithm is as important as a correct algorithm. So thank you students. We will see in the next topic. Okay, thank you.